Hello, welcome to Graphing Systems of Inequalities and Finding a Solution. So here we're going to graph the systems and we're also going to give the coordinates of a solution so we can look at the shading and pick a point. In order to graph these, notice that they're not in y equals mx plus b, so we need to solve for y equals mx plus b. So real quick, we'll go solve 5x plus 2y is greater than 4. I'm going to subtract 5x. So 2y is greater than negative 5x plus 4, because the 4 is positive. And I'm going to divide by 2y over here. Excuse me, divide by 2, so I get y is greater than negative 5 halves x. Oops, getting ahead of myself. Plus 2. So this equation equals, that we're going to graph, y is greater than negative 5 halves x plus 2. I'm going to graph the other equation, we'll do that in a different color, negative 3x plus 7y is less than or equal to negative 7. So I'm going to add 3x to both sides. That cancels it over here and leaves me with 7y is less than or equal to 3x minus 7. I'm going to divide by 7 on both sides. And I get y is less than or equal to 3/7 x minus 1. So this equation changes to y is less than or equal to 3/7 x minus 1. Alright, let's go graph. Alright, I'm going to graph my first equation, y is greater than negative 5 halves x plus 2. So I'm going to go to positive 2, 1, 2. Since it's negative 5, I'm going to go down 5 over 2. We'll do up 5, back 2. And since this is less than, or this is just greater than, it's going to be a dashed line all the way through. Okay, there we go. And since it is and then we're going to go graph y is less than or equal to 3/7 x minus 1. So we go to negative 1. I'm going to go up 3, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7. Down 3, 1, 2, 3, 4, 5, 6, 7. And it's a solid line. Because it's equal to. Alright, so I need values that are less than negative 1, but greater than positive 2. So less than negative 1 is all of these values right here. But then I also need greater than positive 2. Oh, all of my overlap is right here. So now I want to pick a point for my solution set that exists over here. And so you can just pick easy points. You can either pick random ones down the middle, but I'm going to grab one off the x-axis, and it's going to be that point right there, which is 1, 2, 3, 4, comma 0. So the coordinates of one point in the solution set would be 4, comma 0 because it exists where the shading happens. Let's look at one more problem real quick. I have these two values I have these two equations. They need to be in slope-intercept form. Y equals mx plus b. Well, this one's going to be y is less than or equal to negative 4/7 x plus 1. And this equation is going to be y is greater than 5/3 x minus 1. Alright, let's go ahead and graph them. I want to go to where, for the top equation, I'm going to go to x is positive 1. I'm going to go up 4/7. Excuse me, down 4/7. 1, 2, 3, 4, and then over 7. And it's equal to, so it's going to be a solid line. I need to go to -1 and graph. I'm going to go up 5/3. 1, 2, 3, 4, 5/3. 1, 2, 3, 4, 5/3. And this is going to be a dashed line because it's just greater than. That should be more dashed. Okay, now I want to look at where I want to shade, so I'm going to look at where my y-intercept is greater than -1. I'm going to look at where y is less than or equal to +1. Okay, so to shade this, y is less than +1, less than +1's all down here. Okay, so less than, it's this way. And then I want to look at y is greater than -1, which is all this way. And so they overlap in this area right here. And so any ordered pair in this group is going to be my solution point. And if you look, 0, 0 exists right there. So my solution set for this will be 0, 0. You can use any other number. 0, 0 works. All the values on this x-axis work. So you could use 1, 0, -1, 0, -2, 0. You could use -2, 2, things like that. So just remember, get your lines in slope-intercept form, graph them, shade them correctly, dash or solid, find your solution point.